Hello, nice to meet you. We will begin now one session that it's something very nice about which is the last innovations that we can find in the world of infrastructures. In fact, something that is common to cars and trains and people is that we need bridges to join two sides of different territories. And this is what we will be talking about today with Meg Davis. She is Industry Marketing Director in the road department of Bentley Systems. Hello, nice to be with you, Meg.
Hi, nice to be here.
And we will have also Dan Vogen. He is Vice President of the Roadway Asset Management from also Bentley Systems. Hello, good afternoon,
Hi.
Or good morning for you.
Glad to be here.
Thank you so much, because normally the fact that we have found in the BIM environment is that there has been pressure in order to develop as much as possible all the software and applications around buildings. But today what we will be engaged and fascinated is about seeing how all of these developments are applied in infrastructures. Normally, and here I'm from Barcelona, here in Spain, and we can see that architecture has advanced a little more than engineering, but today we will demonstrate that this is not like this. Probably infrastructures are taking a great advantage about how to create what we call a digital twin. And although we have the definition of building digital twin, today we will, let's say, create the definition of bridge digital twin. So thank you so much for being with us. And I think the best is to make a short introduction with a video that will explain us this advancement that you have made.
I was reading through a magazine and saw a picture that was kind of grainy, black and white, and showed several men, bridge inspectors, on ropes hung over the side of a structure. So that picture had been taken in 2013. It looked like it was from the 1960s. We've got to be able to do better.
There are currently over 20,000 bridges in the state of Minnesota. It's important to keep on with the inspections so that we can properly maintain them over the course of their life and find out when the need is to replace them.
We started partnering with Bentley because both of us really wanted to use technology to improve the inspection workflow.
Most of those engineers don't go out in the field much, so it's hard to relay through close-up pictures and trying to explain to them what I'm seeing.
We came to look at Hololens to get an understanding of what's actually happening in the field without having to be there.
The Hololens and the Azure remote rendering was a really unique way to sort of bring the bridge into the office to do the inspection.
Our company has been very involved in the idea of digital twins, of having computer models that replicate what's physically out there in the field.
These images can get right down to the cracks themselves. We can measure the width of them, not just the length. They're that detailed.
We have all this information at our fingertips that we never had before.
If we could reduce the overall expense by 10%, that could be a humongous win. Now, we're talking potentially several times that in overall savings. The graphical processing, the streaming has to be spot on with the Microsoft HoloLens 2 and the Azure remote rendering capabilities. We're able to see accurately, truly geometrically, the impact of changes over time. Everybody says, oh, this is like science fiction, but it's real.
Well, as you said, Dan, it seems science fiction, no? And this is very a good introduction for what we will be talking today. Well, we have a set of questions, and the first one is to try to join. You know that Amazon, all the logistics world is something that is the sector that is growing more and more, and logistics and distribution, last mile, etc., seems to be one of the major sectors that are in exponential development. No? So to maintain the infrastructures, to enhance them, I think is the best that we can do. And then we have tunnels, we have roads, we have trains, we have bridges. But why are bridges so important?
You know, bridges are a lifeblood. We can see where we have a roadway network, and if we have to close down one small section of roadway, many times there's easy ways around that. When it comes to a bridge, we've got that bridge there for a reason. There was something that was probably difficult to cross, and if we lose that crossing, there's often some pretty significant inconveniences. We've seen some pretty significant issues with structures over the last few years. There was the Genoa Bridge collapse, shut down access to a whole area of the city. A few years ago, there was the collapse in Minnesota with the 35W structure, and not only the impact that it had as that happened, but also, again, the accessibility or the lack of accessibility because of the loss of that structure. Just in the last week or two here, we saw the rail structure in Mexico City collapse, and I think it was a loss of about 24 lives there. The stability of the reliability of that infrastructure is so important, so we don't have that loss, as well as then what it means to the transportation network there. And just last week, we saw a structure between Tennessee and Arkansas in the United States find a crack, or really a fracture in one of the members in a big truss. There's 50,000 vehicles that cross that bridge each day. And I saw a comment that was really interesting that I didn't personally expect. We understand the implications for those vehicles that are crossing that structure every day, but they said that there was 700 barges that were backed up underneath the bridge because they had to make sure that the structure would not collapse under its own weight, and they didn't want anything even crossing under that structure as the inspection went on. So, we just see what is there in the importance of the movement of the general public, the importance of commerce and the movement of our goods, and the safety of those who are dependent on that crossing.
Yeah, well, something that also is really interesting for, let's say, for the ICO sector, no, architecture, engineering, construction, operation sector, is this cooperation that you have done between Bentley Systems and Microsoft with the use of Hololens, no? And something that is focus of what we are defining as the fourth dimension of BIM, no? That is planning, no? But also planning is also very interesting for budgeting, for operating, etc. No? I was lucky because 2 years ago I could experiment in the Mobile World Congress in Barcelona. The HoloLens applied in Bentley Systems processes, and it was for me something really amazing because it was the unique proposal from this architecture, engineering, construction, operation sector at the Mobile World Congress. So we are one of the biggest sectors in the world, but let's see, we are far from getting these technologies inside us. No? So I do think that what you are presenting now and what you have been defining in the video is more than the second step of this HoloLens. No, it's something going further.
Definitely agree. And, what you saw a couple of years ago in the HoloLens was with our Synchro application. Synchro really allows the viewer to immerse themselves in a situation and see the condition of the environment they're in. And in augmented reality. That's the power of the HoloLens, is allowing you to see through and see the real world, but to also then see in kind of a hologram basis and in an augmented reality basis, what else is there, or what else could be there, what's planned to be there. And so, Synchro allowed you to see at this level of construction, and then visualize what those next levels would be. It helps to find issues ahead of time in the actual construction, helps to just provide another perspective on what this is going to look like, and make sure that we're moving along with the progress that was expected. It was a very, very important step, and I think it's something from a construction standpoint that's going to be critical for many, many, many years in the future. I think you are right in that this is a next dimension, a real follow-on this. We have around the world so much existing infrastructure where there is some new development that goes on, some new construction that occurs, where it's important to start out with a BIM model and use something like our Synchro to see how we progress through that construction. But with the majority of already as-built assets, we're more in the inspection and the maintenance and ensuring the safety and reliability of those today. And so what you saw in the video there, and what we really have as the next step with HoloLens here, is to take it and allow yourself to actually see the current condition of an asset in that HoloLens with the same augmented reality. And we've needed some very, very significant advancement in what's able to be visualized in the HoloLens, because where we did the Synchro in the past, you could use some simpler shapes and polygons, three-dimensional elements, and model what was happening. When we're using HoloLens for the inspection standpoint, it has to be extraordinarily detailed and allow you to see small cracks and understand rust or corrosion on an element. And so the advancement that's occurred to allow us to go from tens and thousands of polygons to today with the HoloLens 2 and with Azure Remote Rendering, tens of millions and hundreds of millions of polygons to be able to visualize that. It's a huge step forward.
Yeah, and in fact, watching the videos that you have in the Bentley Systems site, we can figure out a new, let's say, complementary BIM use with this solution. No? You were talking about the ropes, the picture, black and white picture, and it is related to what, well, in fact, I have a theory of the 10 dimensions of BIM, and the 8th dimension is health and safety. So, in fact, it would have to be the first one, no? But there is not so many space, and it's the 8th. But from my point of view, it was difficult to imagine how difficult it can be to have access to a bridge structure when you have to inspect it and not from the road, but under the bridge platform. No? And this is something new for us. So have you studied this strong impact due to that we are talking about not only to maintaining bridges and maintaining infrastructure, but also about avoiding accidents and risks thanks to your system, to your application?
We really have, and we've seen it expand so much more than what we even thought could be possible about a year ago. That black and white picture that I referred to there was funny. It was taken in 2013, only 8 years ago, and it was on a structure that was about 800 feet, not quite, probably 250 plus meters above the river bed. That's a huge thing with a huge span, and what was required to have engineers on ropes over the side of the bridge. That bridge is a big structure, a signature structure, one of the most difficult to go and inspect. But that's true of many, many structures. To get underneath a bridge, we see the use of big vehicles with kind of crane arms, snooper vehicles that allow you to inspect underneath. And you're in there, you're suspended over the side, you're ability to move is limited, your visibility is limited to that range that truck has you in right now. And so the ability to work through a model immersively has huge freedoms and benefits that way. There is a safety, but we see this amazingly, with the pandemic. We see how so many people have needed to be able to work from home, or we've wanted to have social distancing and spacing. And you say, when I have to go out and inspect a physical asset, how is it possible that I can be safe and avoid some of the pandemic risks? And the engineering firms that we're working with are saying that they can do 90% of their inspection in the office now. So you have a crew go out and fly that structure with a drone, and then the engineers can stay in an office and do a bulk of their inspection and have limited time on the structure physically. It's also a more effective use of time. If we think about the senior inspectors that we have, they work at a structure and they have to drive to the next one. I would love to try and do a study and say how many hours of a inspector who's been doing this work for 25 years has been spent on the road just driving from bridge to bridge. And you say, that's not an effective use of those people's time. So if we can have a flight crew who just specializes in capturing the structure and building the model, do that, and provide the ability for the inspector to inspect bridges, even virtually, 8 hours a day, we make much better use of their time. So we see the safety, the risk aspects, as well as the accessibility. And it hadn't hit me initially, but not only then do we allow an inspector to work in an office, but we open up the inspection process to many other people. How many inspectors do we have that maybe after doing this for 20 years have a bad knee or a bad back and they can't be on those ropes anymore? They can still be a part of the inspection process, even though they can't physically go out there. How many people might we have with a disability that are in a wheelchair, something like that were never able to go and inspect, and now they've got the engineering capabilities, and our visualization allows them to participate in it. So it's just an amazing accessibility and safety addition here in all of this.
And if I could add to that, I think during this pandemic, there's been a lot of new technology that people have embraced that maybe they wouldn't have been so open to in the past. For example, the prevailing use of drones. And so as Dan said, the safety, the risk reduction to the inspectors is certainly a big piece of this that we see today that has happened during the pandemic, but will also continue forward after the pandemic. And in addition to the safety reduction for the workers, for the bridge inspectors, there's just a significant impact on the general public as well. So that, you don't have to have the lane closures, you don't have to have the disruption of the equipment on the bridges. So we see real impact both for the inspectors and the general public as well.
Yes. Well, this is a good point, because I never thought in this possibility of generating job positions for people that are disabled, but they could perfectly be engaged in this kind of works. No? So it's something really, really interesting. Well, and when we are talking about this digital twin, in fact, from the theory and the first paper by Dr. Michael Graves in the University of Florida, defining what is a digital twin as a concept, your application has created a bridge digital twin. So something that was, let's say 10 years ago, it was a concept. Now we have a very, very strong application. How do you envision future functionalities for it? What are you working in order to push this concept that now is applied in something that can provide, as you were saying, both of you, talking about generating new job positions or better conditions for inspectors, or et cetera, et cetera, et cetera.
Yeah, well, when we talk about a digital twin, we say it is that model of the physical, but that it must also be a quote unquote continuously surveyed or regularly updated. That we can't say I developed a reality mesh, a digital twin of the bridge that was built, I did this 3 years ago, and that it's valid today because something changed with that bridge or any other asset in the 3 months, year, 3 years, 10 years, right? So whether that bridge has been hit or there's been some new corrosion or a crack has expanded or whatever. So we have to find the way to continuously keep that model updated. So I think that's where a lot of the future is going to go here, is how frequently can we bring inputs in that allow us to better understand the actual current state. We see several things happening here, potentials in that regard. Right now, even just so far today, I've talked about drone crews needing to go out and manage the flying of that structure and the capture of the photogrammetry or the video, and then us building a model from that. We're seeing some changes now where there's been laws or different laws around the world where that drone crew had to have line of sight vision to the drone as they were flying it. Some of that is being relaxed. As we see the Amazons and delivery services of the world talk about how they're just going to send a drone out and deliver a package, we see the same thing happening for these structural inspections. If we have a crew go out and fly the structure one time and develop a flight path, can we automate the delivery of those drones to the site and run that and be able to do it much more frequently with much less cost because we didn't have to have that human involvement? So if we're able to do that, how frequently can we keep our models updated? And then it's about what we can do with adding additional sensoring, what we can do with the type of information that we collect in a capture. Can I capture thermal imagery as well as just visual photographs? Can I capture from sensors different strain gauges, different vibration harmonics, that we can see a change in time and flag that and automate what happens with our inspection? And probably the last key part of this is the more that we're able to frequently capture the structure, we can have the computer software do comparisons, and it can look and say, I see that this crack has expanded 3 millimeters or 30 millimeters. I can see that this extent of corrosion has grown bigger. I can see that there's something that this steel beam was hit and it actually is rolled right now. And having that kind of pre-inspection by the computer that says, hey, I see this. Engineer, can you confirm this? Do you need to spend more time looking at it? So we see many things in what happens with a capture and in what happens with our automated understanding of the change in the structure.
Mm-hmm. Following about what we can avoid with these kind of applications is to try to solution something that has happened this last decade about not having enough maintenance of our beaches. You were explaining about accidents in the USA, but in Europe we suffered this Genoa highway bridge in Italy. That this was shocking all European civil engineering societies, institutes, etc. No, because you expect some problems in little bridges, something like this, but not in a highway that it was used around, I think it was 100,000 people per day, you know. And then how do you feel that thanks to bridge digital twins, we could completely change this problem, this scenario to a new one? Do you think that this is something that at least we will be able to avoid these accidents from now to the future?
So I think there's a couple of key aspects in that question there. One is about the monies for maintenance, period. There is a pot of money and a budget and allocation there that everyone has. And one of two things has to happen there. That has to somehow get bigger, and or we need to be smarter with or more efficient with how we spend it, right? So I think we do see that especially the pandemic is pushing nations around the world to look at the monies that are allocated for infrastructure, seeing infrastructure spending as maybe a great stimulus to help us get out of pandemic situations. So hopefully we can see some global funding, global increases in funding that allow us to do better with maintenance overall. Okay, if that happens, that's fantastic. For all of the future, we need to be more efficient with what we do with the funding that is there. And I think that a lot of this digital twin work will definitely do that. If we can decrease the cost of our inspection processes, we can use those savings to actually do the maintenance. So there's a positive there. If we are doing a better inspection process and that we can inspect a structure more frequently, that we have better information, that we can identify changes that were more difficult to observe in the past and do something that's more preventative rather than reacting to a very bad situation that's identified too late, we can do that maintenance with less cost too. So I think there's a whole combination of increased funding, use the funding we have more effectively, take funding that was used for inspections in the past, be smarter with inspections and use it for maintenance. So all of it's complementary and creating a safer and more reliable system in general.
And to add to that, we do have the technology, obviously, to do this. And as Dan said, there has to be the funding, but there also has to be a commitment on the part of the governments or the owners to make sure that these bridges are inspected on a regular basis and to ensure that accidents or incidents don't happen by having these inspections done on a regular basis. So the commitment has to be there.
Well, a commitment probably that, for example, in my country, in Spain, we have all the high roads, I think, and all the bridges are operated by private operators. So it's something that is as easy as when there is the contract to do this, to push them to begin to use these technologies. And it will be a saving for them and a better safety scenario for the government also. Let me remember to all the people that is as the audience with us, if they have any question, any doubt, any recommendation, please write in the questions and answers that you will see here in the GoToWebinar website, and then we will try to have enough time to make these questions, to ask these questions to our guests. So now, trying to go to a more technical approach, could you explain how, after getting the reality, what we say, reality capture picture, how we add data and maintenance requirements to these scan elements? In order that people that is the first time that could get in touch with this or get in contact with this technology, how we can explain that a drone is making some kind of pictures and after we can add information to these elements.
Sure. So what we look at is to try and get very overlapping image coverage of the the asset, the bridge. And so the drone needs to come in and take pictures or video where each picture will have some level of overlap. And with capture like that, we can use software like our context capture software that takes those, what's probably going to be a couple thousand pictures of a bridge, and merge all of that together and create the three-dimensional mesh from that imagery, whether it's picture or that we take frames out of a video. There is a lot of complexity in that, and making sure that you have, angles from above, and especially you think about a bridge and the low lighting and the areas between beams and stuff underneath that's difficult. So there's a science, an art and a science to the capture that has to go on. But we take those images, run them through our context capture, and then create this three-dimensional reality mesh. There's measurement and intelligence that's added to that. And then with that, we can go and overlay any other spatial information that we have. So if we have a sensor or a strain gauge or whatever it is, and we know what's at this position, that's very easy to go and add into that specific position in the model.
Very good. And then when you are creating or including this information, we know the suite, the software suite of building systems that Bentley systems that you have hundreds of different applications. No? So how is necessary to complement this application with other software, other parts of your suite that is covering rails, roads, buildings, etc. Or by itself, it's something that you can use it by its own?
I think our software is really good at taking the imagery data and creating a model. Our software is very good at managing inspection processes around that and having an inventory of the bridges and knowing all of its technical details and its maintenance timeframes and managing the maintenance processes and referencing into these models and being able to show a comparison of what happens with the models. But we definitely need to be involved with many third parties. We don't create drones. We don't have the flight management software for those drones. We don't create the Hololens, like we're using Microsoft and their Hololens. We're dependent on what Microsoft is doing with a platform to be able to render these huge models with, like I said, tens of millions to hundreds of millions of polygons in there. So there is an ecosystem that we work in, and we provide that engineering aspect of the software, and are very dependent on partners to round out the entire extent of what's required.
Very good. Okay, and then what you are talking about today is that this is a technique that for existing bridges, and better, let's say, for all bridges. But what about the new bridges? How we can prepare the new bridges in order that we can do a better inspection, its operation, or how we can take information of the existing bridges and, of the new bridges and bringing this to your software in order that then we already have, let's say, this digital twin, and then to include the next operational visits and inspections that we will do.
Yeah, I think there's several aspects that come into play here. One is, how do we use these technologies to do better as we're designing and constructing new bridges? And there's definitely potential there. We talked at the very beginning of this about synchro and what you saw 2 years ago. And what we would like to see here now is that the scans of these construction environments are done much more frequently. We had a project that was a Bentley Year in Infrastructure winner, I think 2 years ago, with a big natural gas facility where they would fly that whole facility once a week and look at exactly what was changing in its construction and be able to have that whole series of different models over the time and ensure the construction was going on as planned, and work with better estimating and understanding of quantities that were on site, and seeing potential conflicts. So that's definitely applicable as we go through the construction of a new bridge. I think too many times in the past, as the second aspect of this, is that we have all lost the value of the different deliverables and artifacts of different stages of an asset's life. We had bridge design plans, and that was used for construction, and then it got put in a file folder somewhere that's stored with that bridge, but we didn't have the way to seamlessly move that into what we were doing with the operation and maintenance aspect of that bridge's life. And so if we've got multiple scans, if we have the scan of the bridge as it is when it's first open to traffic, that's a huge benefit and a great baseline that we're going to do all future comparisons against, and that we can use not just for inspections, but that we use for the continuous kind of requirements for load rating that structure and making sure that it's maintaining the structural integrity and the load carrying design that was there. So we're doing so much work to make sure that we flow information from design and construction and all of our analytics into the operational maintenance side of things. And one of the areas too is to kind of flip that around. The whole world has talked about that workflow, design, construction, operations, and maintenance. But being that we do have so much that goes on for enhancement now, a lot of times that process can start now with operations and maintenance and say, I've got a situation. What do we need to take into our design and construction for maybe enhancement of that structure? So we can use what we have as the actual as-built at current condition and be more effective with our design and construction, especially for maintenance and enhancement type work.
Well, in fact, it's something that is related to constructability, and pre-construction. So we could understand probably in the future, with the experience of how are done these inspections, we could design better the bridges in order to be better maintained, but better inspected also, probably.
Correct.
And this is something that we have discovered, for example, that some structures with concrete that while engineers were trying to design it, we realized that were impossible to build. So is this effect that BIM can help us a lot. And this is very interesting because if we do one step from software to hardware, which will be the requirements to the drones in order that can fulfill perfectly the requirements of your new application? What do we have to ask to these drones? It's something that probably they need some specific cameras, they need some specific performance or batteries or something like this, something that I could imagine.
Most definitely, yeah. And I'm not the one that's been out doing the flying and to speak to that, but I understand what's needed from the images that are going to be captured basis. And like I say, if you think about a pretty typical bridge that just crosses a highway. That bridge, is deck and parapet that you can see easily from top down. You come over the side and maybe there's 8 or 10 or 12 steel or concrete beams underneath. Mm-hmm. And so we need to be able to work to get the drones, the top-down capture has been pretty easy for quite some time. As we come over the side of the structure and taking our imagery, kind of horizontal. Then the difficult part in getting up underneath and having proper lighting, and the drone being able to take upward looking pictures. So there has been a lot of advancement in that area over time of late. I know from some of our consultants, they're finding great success with the likes of an Intel Falcon 8 Plus or a Skydio 2 drone, and that those are some of the most advanced drones now in being able to change the angles of the camera and have upward facing photogrammetry, and even getting into things where they're trying to navigate that drone very, very close to those beams and having collision detection type capabilities there. So, we put the requirement in the coverage that's required, the overlap of images that required, and these hardware that the drone creators now are getting that much more capable in the angles that they can shoot and the navigation that the drones have and what they can do with lighting. So huge advancements there, and I think we're going to continue to see that go on.
And in the video that you saw in the beginning, our partner Collins Engineers is who we work with a lot to do the drone flying. And as Dan said, they use the Intel Falcon 8 Plus and the Skydio 2. And what they told us is that both of the drones can look straight up, which is obviously a requirement for the bridges. And the Intel has a high resolution camera, which is really important on the larger bridges. And they have good planning software, and the Skydio has really good obstacle avoidance.
Well, it seems like we have Mission Impossible in our hands, no, in our fingertips. It's very nice that to have all of this technology right now. No? Well, it's time for the questions, and we have received the first one. It is about sensoring, and it says which kind of IoT could be necessary to have a real-time twin, in the sense that probably I think is focused on these aspects that right now are appearing about digital twin and digital twinning, no? This constant and continuous information that we need about something in order to make that the digital twin can be something useful, because we have all the information about that. What about these sensoring needs that we can link to these models?
Yeah, that is the key here. You said continuous surveying. That was part of my definition of the digital twin, as we were discussing earlier there, and that we have a model, but it's only so good if we are unable to keep it updated. And so how many different inputs can we use to keep that updated? And again, I guess I would go to, we see several types of inputs that will happen. One is what we get from imagery and video capture. So how frequently can we do that? I don't really count that so much as an Internet of Things or a sensoring basis, but it's a really, really key part of understanding change, because what we can get visually is extremely important. Beyond that then, and what we can get into in sensoring, there is much that's going on to instrument newer structures with some in-place video, so that you can actually see if there's certain kind of deflection that's going on, that there's a change in that deflection. And so we could use those real-time cameras and update parts of the model. We can work with strain gauges that would come into play and look at vibrations and harmonics and anything that may be changing that way. We were just in a discussion over the last couple of weeks when you look at some of the larger, most complex structures with large cables, some of your stayed cable structures, that there's only so much that you can get and understand from visually looking at that cable, that, as I understand it, many times loss can come from inside of that cable. And so we see equipment that's able to go out and kind of run a robot up and down those cables and do some various magnetic detection and kind of imagery creation to understand that there's section loss going on inside of that cable. And so taking any input like that and getting it overlaid on the model that we have, and then using the tools to just detect change, that something is changing in the inputs that we have. And so the more that we have that we can bring in, the better that model is going to be overall.
And then about this detection, is there any restrictions on the lighting required for the service? There is a question from Neil Dance that he's asking directly, can the drone be used at night? This is a question.
I have not seen any night capture yet. I don't know that we'd be able to create a good enough model from that. Be interesting to see if, depending on what it is exactly that we're getting from that, if we're able to light it up enough, and if we can see that there's a good enough ability to align the different images, it may be possible. There may be things that we could do with thermal capture or LiDAR capture that wouldn't be dependent on natural lighting, where those could come in and affect the model. But as far as I've seen, about everything from a pure imagery and what we would use for the main visualization requires good lighting.
Meg, something to add to that?
No, I think Dan covered that. I've not seen it at night either, and I think you really do have to have sufficient light to be able to get a good capture.
Yeah, we are working with SARS satellite images, and SARS is a technique that is using microwaves, and it seems that in very few time we will be able to have night images of something without having light. So let's see how it's being developed.
And like I said, I think there's certain kinds of data collection that can work that way. If it is, like I'm flying this and I'm trying to get a thermal map, as long as we're able to safely fly that drone and we're looking at thermal imagery, it's not, we're trying to look, under the skin of the bridge and see some of what's going on, and that can be very, very possible there. But what we have with actual visual appearance is probably going to require some level of lighting.
And we have another question from Milen Korsarski. Is how do you deal with the underbridge drone flight threats such as GPS loss or wind currents? How do you solve this, or are you thinking in solving these problems?
Yeah, and that I am probably not well enough qualified to do that. We've been working with several partners. Meg referenced Collins Engineers there, and they're out in the field doing that and working that constantly. Be glad to hook them up with some contacts there and talk about that. I know it's being done, but I can't speak to the drone piloting myself.
Well, this is something I would love to be a drone pilot. I think all of us would like to use them in this way, no? And it's something interesting because these the signals about GPS, etc., but also the weather conditions, no? Because probably we can have some stress infrastructure because of snow, because wind, because tornadoes, etc., no? And how we can do, let's say, an anti-tornado drone to make stable images, etc., or these kind of conditions of a tropical rain. I'm thinking in India, for example, or these Asian countries that are suffering big rains for that. No? And we have another question, and probably he's Indian because his name is Abhilash Pradhap. He's asking how you consider the possibility of seeking second opinions or joint inspection with multiple disciplines through this digital inspection. If this, probably he's thinking in well, this is some information that appears in one maintenance engineer in his office, or this is something that could be shared. We could have a common data environment for these images and to have better opinions, no? or other opinions about what could happen in one of our bridges?
Yeah, what a great question. It's something that we are definitely working on right now. We see a couple different aspects to this. The very first is easy access to the same information from multiple experts. So if I am looking at a model in the Hololens, we are creating and enabling right now the capability to say, I want to call in Meg to take a look at this with me as well. And so from right in the application, I can introduce another person to say, look at this, what I'm seeing right now. What is your input on this? Do you feel something differently about this? And so we'll be able to see all kinds of collaboration that way. Another aspect that can come into play and how we use this and work with this in terms of different expertise is if I were a very senior inspection engineer and I may be working with this tool in the office, I can go and observe different things, put notes right in that model and say, this really needs a hands-on look and double check of what we're looking at right here. And then I can have somebody else out in the field with the augmented reality aspect here that's seeing the physical structure and also seeing the notes that I've put on the model of the structure. And so it can point them to that condition very, very quickly, have them focus on those limited places that the senior inspector has identified and work through the process in a really efficient and kind of collaborative way that way.
And I think in addition to what Dan said, the technology is going to enable you to have engineers and the project teams to collaborate regardless of where they are and have that single source of truth, that they're seeing the same information and ensuring that it's up to date and correct.
Well, this is also something related to the next question, that is, it says that something that I envision with your solution is the fact of having a track of the history of the inspections. And I will add, well, this will help extraordinarily the inspection cost, but also the diagnosis, no? Because it's something like, let's say, when you go to, well, I'm a fan of a Netflix TV series called New Amsterdam, that is in one hospital, no? And there is one doctor, quite old doctor, that he is always right because he has all the experience over him, no? So let's say that because he knows what has happened in all of his patients, he has a client diagnosis, no? A clear diagnosis. So I think we could add artificial intelligence, let's say, no? to this process in order that it's different if we can see a fracture of 3 millimeters or 3 centimeters. So we could say if there is an urgent necessity or not, or etc. No, this is opening a new field on that.
I agree totally. I love the show you referenced to, but agree totally in the possibility that comes in the information that we have, the accuracy of the information that we have for the inspections. I've been asked a similar question a number of times, and I'll give an example here, and I'll share it here. We've had inspection processes, regulated, mandated inspections for structures around the world. Those processes have typically required us to make handwritten notes about conditions we see and to take pictures of what we see. And if you go and look at a structure that's 30 years old, you'll see a huge file of all the inspection reports that have been created for that bridge over 30 years, probably every other year, and hundreds or thousands of pictures. But you talked about there just the understanding of how a crack has changed. And my example is, if you take a camera out into your garden and take a picture of a flower, today, and then try and take the same picture tomorrow, just tomorrow, not a year later, not 2 years later, will you be the exact same distance away? Will you be at the same angle? Will you be able to look at those two pictures and say this flower grew 2 millimeters or 10 millimeters or what? And it's extremely difficult to have that consistency. Now you talk about a structure that's 100 meters or 200 meters long or whatever, and how many pictures you were taking on that, and how can you look at two pictures of this crack from 2 or 5 or 10 years and say, I really understand what's going on? But with these digital twins, we have geometrically accurate information about that. And when we go and see that this crack is 3 millimeters here and 5 millimeters here, without a doubt, we are 100% sure how that crack has grown over that time. And we can create that much more reliable understanding and that much more reliable prediction on what's going to happen.
Yeah. Well, it's a pity because time is disappearing. It has been 1 hour with you, and for me, it seems like 10 minutes of conversation. Well, we have 2 other questions, one about immersive inspection and another one about real capture, but we do not have time. I have a list of other questions also, but I have to thank you, Meg, for your time, and Dan for being with us, showing us this amazing, I'm an architect, but for me, it's something amazing to begin to imagine how all of these uses can be also extrapolated to the field of building construction. Mm-hmm. But also it makes me, let's say, nearer to the world of infrastructures, and also how it's amazing how BIM, that only 10 years ago we were talking about making 3 digital models, etc., how we can now solve probably very big problems of our infrastructures in our countries, and to keep better our businesses, our logistics, our people, and all of the activity that we have on them. No? So thank you so much. I think that it would be a very good recommendation for everybody that can listen and be and watch us right now is check the site of Bentley Systems, because there is a number of different videos, each one of them that is more open-minded than the other. And thank you so much, because today I think we have not been talking about the world of construction, we have been talking about the construction of the world. So thank you so much.
Great phrase.
I hope to meet again in any time that you think that we can make a second part of this video, because we have or you have had or you have arrived to a new technology, a new application, or something that can help all of us to have a better society. Thank you so much.
Fantastic. Thank you, Ignasi.
Bye-bye.
Bye-bye.